Okay guys, we're continuing with chapter 5. We're now going to talk about inverse relations and functions. Remember that a relation is anything that happens between two numbers. For instance, if I have y equals 2x, the relation is that 2 times x yields y. So these two are related by a multiplication of 2. Because if I multiply x times 2, I get y. It's a simple concept. A relation is something that connects an x and a y, or an input and an output. And this is a concept from Algebra 1. Now, a function is a special type of relation in which the x's never repeat. Remember that if I had repeating x's, like if I have a table, let's say that this is a relation. If I have this, it is not a function because the x values are repeating. So that was a quick review from Algebra 1. Right now we're going to talk about, well, let's first go over our objective. Today the student will be able to find the inverse of a relation or function. In this case, notice that we do have a function because no x's are repeating. The 1.2 is paired up only with the 1, 1.4 is paired only with the 1, 1.6 is only paired with the 2, and 1.9 is only paired with 2 as well. So this is the relation R. It happens to be a function. This is the domain and this is the range. Let's take a look at its inverse. As you can see, all the inverse does is kind of switch the domain with the range. It kind of undoes whatever R does. So if I add here a given number, it undoes it. It kind of, okay, to keep it simple, it just switches the domain with the range. So let's go ahead and take a look at an example. Look at this example. Example 1. What is the inverse of relation S? So we have relation S here. Something happens to x, and then when my input is 0, my output is -1. I don't know exactly what relation S is or what it does mathematically, but I know that when my input is 0, my output is -1. When my input is 2, my output is 0, and so on. So let's say that I want to find the inverse, and if you look at the table above, all that happens really, I had my relation R here, and to find the inverse, I literally just inversed or reversed the domain with the range. With the domain with the range. So I'm going to go ahead and do the same thing here. So to obtain my inverse relation, I'm going to switch domain with range. What do I mean by that? I'm still going to have x and y here, but where I had my x's, I'm now going to have my y values. So in other words, the y values from my original relation become the x values from my inverse relation. And vice versa, the x values from my original relation become the y values or the range of my inverse relation. And we are done, guys. We found the inverse relation table of S. Okay, so next we're going to explore what inverses look like when we graph them. I'm going to take the same relation S that I used in the previous example, and we're going to look at what happens when I graph this. So I'm going to take S. All I'm going to do is plot the points. We have 2, 0, 3, 2, and 4, 3. And I'm just going to leave it like that. So I'm going to go ahead and get the inverse, which is negative 1, 0, 0, 2, 2, 3, and 4, 3. I want to show you what's actually happening here when I find the inverse. Ignore this for now. Here we go. This is what I'm looking for. I want to make a line over here. And this is going to be my line y equals x. And this is the difficult part to understand for most people, but I think we can figure this out together. So this is my y equals x line as a linear parent function. This is again from the beginning of the year, review from Algebra 1. This is my linear parent function. And for a moment here, I'm going to go ahead and plot the same points. I'm going to use a different color so you can see what I mean. So I'm going to have 0 on this point. Okay, so next. I'm going to go ahead and plot these points on their own grid. So I have negative 1, 0, 0, 2, 2, 3, and 4. Oh, I made a mistake. This was supposed to be 3, 4. So this is supposed to be 3, 4. So if I graph them, notice that there's not much of a difference. You can kind of see that you can't really tell the difference when you graph them separately, like here and here. But over here, if I go ahead and put them on the same graph, it's going to be clear that they are a reflection across this line. And that's an interesting part about this. In pre-cal, you're going to learn this in more detail, but inverses inverse relations are a reflection of each other across y equals x. And what I mean by a reflection, you can tell here that these two are reflecting perfectly. And again, the direct thing to do is just switch x and y, but I also want you to understand what's happening at a deeper level, okay? So they are reflecting, because we're changing x and y, they are reflecting across this line. Because you're exchanging these two values, they are reflecting across this line. Second example. Now, let me read it for you. What is the inverse of the relation described by y equals x squared minus 1? So now the difference in this case is that we are given a relation now. We're given a function specifically. We know that this is a quadratic function. So we want to find the inverse, and the approach is going to be the same. What we did before was we switched domain and range. And what I want to leave clear here is that domain is, we know all the possible x values, and the range is all the possible y values. And I'm putting that in parentheses just so that you know. So essentially what we're going to do in this case is the same thing. So this is before, right? So now we're going to do the same thing. So now we repeat the process. only that we're going to be more specific about what we're switching. And instead of y, I'm going to switch it with the x because that's what we did before, right? And everything else in the formula stays the same. So now what we're going to have is, notice how we switched where the y was before, we now have an x, where the x was before, we now have a y, exactly like we did with the tables. So the only step we're going to add now is solve for y. And how do we do that? We applied good old algebra. So I'm going to do that on the side. And I'm going to use one color for that. So we have x equals y squared minus 1. We want to solve for y. We want to leave this guy alone. So clearly, I have to do what we've always done. Add 1 to both sides. Isolate my variable, like we always do. This becomes 0. This becomes x plus 1. And at this point, you have to ask yourselves, how do I get rid of an exponent of 2? And there's two ways to do it. I'm going to do the most common one, and I'm actually going to erase it. I'm going to square root it. Notice that we have an index of 2 here. What I do to one side, I do to the other side. The exponent and the index cancel out. And I'm going to write my answer here. So y equals positive or negative. Remember that we always have a plus or minus in front of the square root. Square root of x plus 1. And when you really think about it, it makes sense that the inverse of a square is going to be a square root because they're going to kind of undo each other, for lack of better words. So this is a simple and to the point example as to how to find the inverse of a function. Switch and solve.